Hi, this is my recording of example 12.8, okay, which is basically uh, providing a hypothesis test of, of rho or the correlation coefficient, okay? So this is the tail end or the last part of chapter 12. We learned about hypothesis testing of rho, is the true correlation coefficient. We don't have that, but we can estimate one. This is R using the data. And I outlined how to do hypothesis testing, and I've never done, and I didn't do the example. So this is my recording of the example. Okay. Let's do example 12.8. 12.8 says refer to the height and weight data in example 12.7. That's where I put the data in. It's right here. Okay. And I already copied and pasted the data here, okay, into Excel. And then it says the correlation of height and weight was calculated to be R, which is equal to 0.8261. Is the correlation significant? So what we are trying to do is do a hypothesis test of rho, rho equal to 0, okay? So that's our hypothesis test, given that R, the estimated value, is 0.8261. So what I'm going to do is move the Word file out of the way, and so I could expand the Excel file. Let's move this out of the way, expand the Excel file, okay? So let's do this. Well, they said the calculated uh, uh, R, or correlation coefficient, is 0.8261. We could figure that out two different ways using the Excel formula and also running a regression. So let's run the regression and just for practice sake. So we go to data, data analysis, regression, okay. And let's clear all this. All right. So I'm going to first input the y variables. Here's the y, that's the height. Input the x variables. Here's the x's. Oh, wait, weight. And then height is the x's, sorry. I included the labels. So I click on labels. Confidence interval, I want another one, so I'll just put in 99. And output, I want to put it here into the same Excel file. So I'll put output range, and we'll start it from here. So it'll go like this. I'm not going to click any of these other things because we don't need it. And then let's do OK. So here is the output. I'm going to scroll out and do some formatting to tighten up the space. I'll do 3 decimals for kicks. Okay. This one is a percentage, so I'll put it in percentage, 3 decimals. These 3 decimals. These p-values are percentages, and all of these 3 decimals. All right, so I'm gonna tighten. Okay, good. All right, so rho or R, estimated rho, which is R, right here. Okay, that they spit it out as part of this regression. You could also calculate it equal to core L, open parentheses, and you gotta put in your X's or R's, it doesn't matter, without the labels. Put in my X's first, you don't have to, comma, and your Y's, doesn't matter which order, close parentheses, same thing, okay? So there's 2 ways of calculating that. All right, so there's your rho or R. I mean your estimated rho, which is R. And we want to do a hypothesis testing, okay? Whether rho is equal to 0. So create our hypothesis, the hypothesis, and our null, okay? Our null hypothesis, here like this. Our null hypothesis is that rho is equal to 0, and our alternative hypothesis is rho is not equal to 0. So that's our two hypotheses, okay? The null and alternative. Step 2 is calculating the test statistic. And this test statistic formula found in the notes, as well as the online recordings. And this is equal to R times, and I'll put it in. Right here, R times the square root n minus 2, 1 minus R squared. It's kind of complicated. So let's try to do it in one go, one formula, but if need be, we could break it up. Do that. So we got, which is test statistic T, okay? And that is equal to R times, open parentheses, and I'm going to put a second parentheses for the numerator, n minus 2, which is 10 minus 2, close that parentheses, inner one, so that's the numerator, divided by the denominator, which is 1 minus R squared. R squared is right here. Link it to that, or you could just do R and square it. Okay? And then that whole thing, excluding that first R, has to be to the 0.5 power. Okay? So what I mean by that is everything but the F5, F4. Let's enter, and I got 4.414. Yeah. All right, so that's our test statistic. Now we have to do the testing. Okay, and I will do the testing. Let's do it down here. Okay. And there's two ways of doing the testing. And there's the critical value method, and there's the p-value method. We're going to do both here. And there's one thing we need to remember. Well, there's two things. One, we need to know the degree of freedom. The degree of freedom is equal to n minus 2. And the other thing is this is a two-tailed test. So we got to have the alpha, or we have to double the tail probability to calculate the p-value. So remember that. We got to keep that in the back of our head. And we're going to do the testing. And they did not tell us what alpha we should use. So I'm going to keep it simple and stupid and use an alpha of 5%, okay, to do the testing. All right, so let's do the testing. And let's do the critical value method first. Critical value method, okay. And in the critical value method, we compare the test statistic against the critical value. The critical value is the t-stat given we have alpha, in this case, half an alpha in the right tail. Okay. Okay. So to calculate the critical value, we know what alpha is. This is equal to 5%. We're doing a two-tailed test, so we need alpha divided by 2, which is equal to alpha divided by 2.5%. Okay. I don't know why this is bolded. Unbolded. And then we got to calculate the critical value. Okay. And the critical value, oops, daisy, is of half an alpha. It's t dot inv, and we want half of an alpha in the right tail, so we have to do 1 minus half an alpha, comma, degree of freedom, close parentheses, and there it is. It's 2.306. And now we got to do the comparison. Okay, scroll down, which is critical value against test statistic. Let's write it out. Critical value, test statistic. And it looks like the test statistic is bigger. And if the test statistic is bigger, that means we reject the null. Okay. That rho is equal to 0. That means rho is unlikely to equal to 0, meaning rho is different from 0. In our case, we calculated the rho to be positive, meaning as x goes up, y goes up as well. There's a positive relationship between x and y. Let's do this again and do the p-value method. Under the p-value method, we have to calculate the p-value and compare it with alpha. Okay. Since we're comparing with alpha, we need to calculate, and we're doing a two-tail test, we need to calculate the tail and double it to calculate the p-value. So the tail, we calculate the tail using the test statistic. So we'll do tail, and I believe the test, oh yeah, that's going to give us the left fat tail, and that is equal to t dot dist, and we put in the test statistic, comma, the degree of freedom, comma, true for cumulative, and it gives us this. And that means our right tail is equal to 1 minus this dude, okay? And again, there's a second way of doing it, which is t dot dist and rt, and then you put in your test statistic, comma, degree of freedom, and it'll just directly give us our right tail, and you don't have to do the fat tail and 1 minus that. There it is. Either way works. Don't worry about it. And then the p-value is 2 times the right tail. Okay. So let's do our comparison. P-value and alpha. The p-value is clearly less than alpha. So that means, again, we can reject H naught, that rho is equal to 0. Okay? Both these two tests should give us the same result. We are done with this example recording, a recording of the example of doing hypothesis testing. Have a good day.